Hey everybody, as mentioned, I'm Andy Garcia and I'm a solutions architect at Ticketmaster. We've been using Apollo GraphQL at Ticketmaster for a little over a year now, and we got a lot of value out of our initial schema, but as we began to build on it, we thought it may not be flexible enough or scalable enough for the upcoming features. After a deep dive analysis, we realized we needed to rethink how we were designing our schema to meet not only the current needs, but also the future needs. So today, I'm going to talk about how we designed a future-proof schema using Apollo GraphQL, and we developed a simple three-step process to ensure our schema could stand the test of time. Our goal was to make sure that not only does our schema serve today's needs, but it also is ready for the future without requiring constant overhauls. So let's dive in. Our three-step process goes like this. Step 1, identify core business objects. Step 2, map your relationships between those objects. And step 3, enrich those objects with data. Let's dive deeper into step number 1, identify core business objects. What are core business objects? Your core business objects are tangible or conceptual objects that are critical to your business's operation. These are going to be the building blocks of your schema, the fundamental pillars and foundational pillars that we're going to build everything else upon. And looking ahead, these are likely to be your first entities in a multi-subgraph federation. So how do we identify what these core business objects are? Just like any other product, we need to understand what the personas are of the end users of the supergraph. Who are the people or services that are going to be using your data? How would they communicate that data to others? And what words are they using when they talk about your data and your business? I recommend that you put together sentences that represent your user stories, similar to that of an Agile user story. When you're done, take a look at the words that you used to craft your stories. Really take time to think about why each word was selected and that it fully encapsulates the intent of the user story and that it's specific enough for anyone to understand. The distinct nouns in that story are the really good candidates for your core business objects. So let's take a look at a simple example for something resembling Ticketmaster. As a Broadway fan, I bought 2 tickets to Aladdin for Friday night at the New Amsterdam Theater. What are the nouns that we use in this user story? Well, we got Broadway fan, tickets, Aladdin, Friday night, and New Amsterdam Theater. Now let's start looking at which of these might be core business objects. We've got a Broadway fan that can be represented by an account. An account is going to be defined as something that allows a user to access the website. A ticket can represent itself as a ticket, and we can define that as something that grants a fan or a user access to an event. Aladdin is a specific instance of a show. So we could use show, but we also know that Ticketmaster sells tickets for more than just shows. We need something that encapsulates the other types of objects of the tickets being sold as well, such as the sporting events. And the word event comes to mind, and this covers it well and would be defined as a scheduled live experience requiring admission. And then finally, New Amsterdam Theater. This is where the event is happening. This is known as a venue. Now, what about the noun that we skipped over? What about Friday night? Let's go back to our definition really quick. A core business object is a tangible or conceptual object that's critical to your business's operation. Friday nights are better represented as a date and a time. It doesn't necessarily fall under a core business operation. It's very important so that fans know when to go to the event, but that makes it information that is likely to belong on the event itself. The distinction is that we don't have to explicitly deal with dates and times, but we do explicitly work with accounts and events and tickets and venues. So the example looks good so far, but I also know that there's something in our ecosystem called an order. Where does that fit within our user story? Let's go back. As a Broadway fan, I bought 2 tickets to Aladdin for Friday night at the New Amsterdam Theater. Is an order represented anywhere in this user story? Yes, but it's really hidden behind the words we chose when we wrote this user story. Look at the word bought. Buying tickets was way over-encapsulated. How do fans actually buy tickets at Ticketmaster? What they do is they place an order. And we need to change the language of this user story to reflect the placing of an order. So here's our new story. As a Broadway fan, I placed an order for 2 tickets to Aladdin for Friday night at the New Amsterdam Theater. Now we have our 5th noun to add to our list and our 5th core business object, order. And what this is going to represent is a singular purchase from an account. You can draw 5 circles to represent these core business objects to start graphically representing your schema. We've got account, order, ticket, event, and venue. And to translate this into a GraphQL schema, you simply have 5 types. We've got 1 type for each core business object that we've recognized so far, and with each of those is the definition of each object. I really recommend that you include your definitions as you're going through this process to make sure that you can have consistency amongst your language. And because we can't leave a GraphQL type empty, we simply included an ID field, assuming we have a unique way to identify these objects. Some best practices I recommend when you're identifying core business objects is go into this exercise with an open mind. Don't be afraid to make changes, and don't be afraid to do many iterations as you go through this process. Next, ensure you're being extremely intentional and precise with your word choice and your overall language. Be very specific and very consistent as you talk through these objects with your team and your other colleagues. Precision of your word choice is going to be a top priority in this step. And if you get confused or are lacking understanding on what a core business object is or what something means, don't be afraid to ask a lot of questions. Comprehension of everything in this step is going to make the next 2 steps way easier. And generally speaking, avoid a lot of detailed design techniques, such as object-oriented design techniques. There's going to be a lot of similar themes as you go through this process, but the important thing here is to understand the language and what is absolutely fundamental to your business, not necessarily every single object that could ever exist within your ecosystem. Thinking in terms of object-oriented design could bring you way too far into the details, and you'll get lost in the details. Finally, avoid using domain-specific terminology. While domain-driven design allows you to use context for your ubiquitous language, the supergraph is likely going to cross multiple domains and potentially all of them. When you have collisions on words between domains that truly represent different business objects, come up with a different word, because what you want to aim for is ubiquitous language across all of your domains. So that wraps up step number 1, identifying core business objects. Let's go on to step number 2, mapping relationships between objects. This step is going to be crucial because the relationships between your objects are what make your graph powerful. They help you define how your data can be navigated and queried. What we're looking for is how do these different nodes interact within the business? How do they relate to each other? How do they interact with each other? In this step, we're aiming for cohesive interconnections. And as we go through this process, you're going to decide between 2 types of cardinal relationships, one-to-one and one-to-many. And you might be thinking, what about the many-to-one, or what about the many-to-many relationships? And those will technically exist in your schema, but we're only going to be looking at the relationships between objects from one object to another object. We end up only needing to know if the relationship is a singular reference or if it's a reference to a list of objects. Let's go back to our user story and look at the example. So our user story, as a Broadway fan, I placed an order for 2 tickets to Aladdin for Friday night at the New Amsterdam Theater. Our first relationship in this story is going to be between the account and the order. So we're going to add a line between account and orders, and we're going to call this new field orders. And the cardinality is going to be one-to-many. In the story, we placed a singular order, but it would be silly if we only ever allowed an account to place 1 order, so its cardinality is one-to-many. The next relationship, the order contains 2 tickets. So we're going to add a field or a line between orders and tickets and call it orders purchased. There's 2 tickets on this, so cardinality is at least one-to-many. We can go through this process with the rest of the story, and we have a ticket to an event. It's for exactly 1 event. You can't get into more than 1 event with a ticket. And then the event to the venue. Similarly, the event can only take place at 1 venue. Now, you should map all of the relationships required to fulfill the stories that you created in step 1. And each relationship should represent a valid and common use case from the stories. And you also might want to add some other relationships that aren't exactly represented by the user stories, but they are common enough to easily add here. For example, we know that an order was purchased by an account, so we can go from order to account and maybe call it purchasing account. We can also do ticket to order because we know that the ticket was purchased via an order, and we'll call that purchasing order. But to keep it a little bit simple for the sake of the presentation, we will simply stick to the user story. So here's what your schema might look like. We have added a couple new fields to our objects. On the account object, we've added the orders, and this is represented by the orders the account has placed. On the ticket object, we've got the new event. That was a singular one-to-one relationship. On events, it's for the venue. Order has tickets purchased, which is the array of tickets. And we didn't add any new relationships to the venue. Some best practices here. Keep it simple. You don't need to map every possible type of relationship. Just like in step one, we're just doing the core critical relationships of your business. We also want to make sure we're using that language from step one. Be really consistent and be really precise with the words that you choose with those relationships, because we don't want to get confused by introducing new terminology that we didn't define in step one. It's really common to start adding words to your relationships when you start calling objects by a different name. Go back and make sure you're being consistent and call each other out. It's okay. You can go back to step one if you need to add new words. And lastly, as you're naming these fields, you need to be really precise. We went a little quick and just called things orders and event and venue, but one thing that we did do was the relationship between the orders and the tickets, we called tickets purchased. And this was very intentional so that we can make use for future compatibility in case there were tickets that weren't necessarily purchased or maybe canceled tickets on that order if we wanted to move it. So be precise with the naming, but again, you don't have to get it right the first time. So that wraps up number two, mapping relationships between objects. Final step, enrich those objects with data. In this step, we're going to add the most valuable fields to each object that can provide enough context for the common scenarios that we discovered in step one. As we do this, each field that we add to the object should provide enough value to the object independent of the relationships with the other objects. We don't want to be going through adding fields that have the perspective of some other object, or maybe some changed value on the existing object. It has to be independent of anything else. Next, be really careful here because we don't, again, want to add every possible field because the final resulting fields need to be determined using demand-driven design. So, just like all the other steps, keep it really simple. Don't add everything you can think of. Just add enough data or enough fields to get the context of what type of data that object can contain. Now the question remains, what do we do with data that does need context of a different relationship or it does need context of another object? For example, let's say that we allow a purchased ticket to be assigned to a different account so the other account can use it. Where do we store something like a timestamp of when the ticket was acquired by each account, since those might be at two different times? We've got to create some intermediary type that makes space to store information that exists only between the two objects. What this does is it creates one layer of separation between the objects, and it allows for the exposure of data that exists solely between those two objects. And more often than not, you're going to encounter this in a scenario that has the one-to-many relationships. This is going to be your lists of information. Now, the connection specification contains a type called an edge, and that's a perfect spot for this type of information. This connection specification is a standard that's been popularized by the Relay client, and I recommend that for most of your fields that are going to contain lists of information, that you use this connection specification from the beginning so that it allows for future compatibility of unknown edge data. And it also provides a really nice standard for pagination. In this specification, it contains edges, and that's where this data is going to be easily exposed between those two objects. Let's look at the schema here. This is what the connection specification is roughly going to look like. On the left side here, we've got our existing core business objects, account and ticket, from the earlier example. On the right side, we've got three new objects, account tickets connection, account tickets edge, and page info. You'll notice on the account object on the left side, we've got a new field called tickets of type account tickets connection. This is going to represent a list of tickets the account can access. The account tickets connection is the beginning of the implementation of this connection pattern, and it contains a list of edges, and it also contains the page info. Each of these edges is where we're going to store the data that exists solely on the relationship between the two objects. And in this case, it's the account ticket edge. And that's what contains the acquired at field that we just talked about in the example. This is going to be the time that the account acquired that ticket, whether by pending, or whether by assigning that ticket or by purchasing that ticket. Lastly, we have the page info object, and this is another part of the specification. I recommend using it anytime you are returning lists of information, because pagination is going to be really important for your performance. But it's also really important to note that this specification, it's not a hard rule. It's just an opinionated tool. You don't have to use all of it. You don't have to use any of it. What it's going to do is just make your life a little bit easier in a more standard way. So here's our schema so far. Looking at specifically the account and ticket objects. We've added fields like first name, last name, email. We've got our tickets connection that contains that data that is in relation to the other objects. On the ticket object, we've got things like seat name, row name, section name, so you can find where your seat is within the event. All this information is very explicit to the object itself without requiring the context of the other relationships, with the exception of our connection object. Some best practices on step number 3. The fields on the objects should be able to be read like grammatically correct sentences. Bob Martin, in his book Clean Code, says, "Clean code is simple and direct. Clean code reads like well-written prose." And I would argue to say that this can apply to your schemas as well. A clean schema reads like well-written prose. Navigating through your schema should be like reading a novel of how your data is laid out. Next, keep your data fields objective. If you find yourself saying, this field is this value from this object's perspective, and a different value from this other object's perspective, that's not changing the key in your entity, then consider putting that data on the relationship between two objects with the intermediary type, such as the edge field on the connection pattern. Just like all the other steps as well, keep it simple. When you get enough of an idea of the fields on each object, stop adding new fields. So now we've got our first draft of our schema. How do we verify if this schema is actually durable and it can stand the test of time? What we're going to do is we're going to start what-if stories. We're going to start exploring what would happen to your schema if we were to get this brand new requirement. So here's an example, our new user story. As an event ticket holder, I want to see all the events I have tickets for. Not something that we originally planned for, but we can look at the story and say, what are the nouns? We've got event ticket holder, events, and tickets. Do we have any new nouns in this user story? Yeah, event ticket holder. But it can already be represented by one of our existing types called account. The fan here is simply wanting a list of events, and they don't necessarily need to see tickets if you read the story carefully. So the relationship is going to exist solely between the accounts and the events. We're going to call this new relationship events. And it's going to be defined by the list of events the account has tickets for. And the cardinality, one to many, because they can have more than one event they have tickets for. And after adding our new line here, it's simply an additional field on the account object. All the way at the bottom, we have our new events, and as a reminder, this is a list field, so we want to use that connection pattern to allow for the future proofing of potential edge data. And then also the built-in pagination schema, at least. How about one more example? News story. As a Broadway fan, I want to see what the available tickets are for Aladdin on Friday night at the New Amsterdam Theater. Now, the Broadway fan here is simply going to be browsing data in this example. So there's no ownership of data between the account and the events or the tickets. The relationship of the data is simply going to be between the events and the tickets. So we can draw a line between events and tickets, and we're going to call this the available tickets. Now, there's obviously going to be more than one available ticket for an event, so cardinality is one to many. Additional field, check, it's backwards compatible, it's not going to blow up our schema. One more durability check. What about viewing sold tickets? Maybe possibly from some support personnel. Here's the new story. As a New Amsterdam Theater employee, I want to see what the sold tickets are for Aladdin on Friday night at the New Amsterdam Theater. And new noun, New Amsterdam Theater employee. Now, this doesn't necessarily fit our definition of an account, so this might be a new core business object if we had some more time, but really, this is actually just a question of authorization at this point, because the real data that we're looking for is a list of tickets for an event again. Now, we already have a line between events and tickets that's going to be represented by the available tickets. So what do? Oh, it's perfectly fine. We can just add another line between events and tickets, but we're going to call this one sold tickets. These are each going to have their own context and their own definition. It's perfectly okay. It's well defined, and it's a simple addition to our schema. So the event object looks like this. We have our original ID, the venue that we added from the first relationship, our available tickets, and then our sold tickets. They're each their own field that can be resolved independently. At this point, our schema is durable enough to handle the stories that we added after our original draft of our schema, so check. It is durable and can stand the test of time, so far as we know. Using these 3 steps, you can make sure that the schemas that you build will be durable enough to handle the requirements today, and ensure that they're flexible enough to handle the requirements tomorrow. Just identify your core business objects, map the relationships between the objects, and enrich them with data. And as a final tip, it's never going to be perfect, and you're never going to be able to predict the future. Just keep your model true to the core of the business and keep it simple, because truth and simplicity will itself stand the test of time. Thank you.